Okay, in the second part, okay, population and sample, I would like to point out pair samples. Or sometimes we call it dependent samples or paired sample t-test. Okay, when using a hypothesis test for match or pair samples, okay, the following characteristics should be present. Simple random sampling is used. Sample size often small. Two measurements samples are drawn from the same pairs of individuals or objects. Differences are calculated from the match or pair samples. Differences from the sample that is used for the hypothesis test. And either the matched pairs have difference that come from a population that is normal or the number of differences is sufficiently large so that the distribution of the sample mean of differences is approximately normal. Okay, just have an idea. Okay, by having a look at these 10 items, 6 items. So when you see the example, you get more understanding. So in a hypothesis test for match or pair sample, subject are matched in pairs. Imagine XY, XY, and differences are calculated. You can to measure the difference between the 2 points. Okay, the difference are the data, and the population means for the difference, we call it mu d. Is then test using a student t-test for a single population mean with n-1 degree of freedom, where n is the number of differences, and the test statistic t-score is equal to x bar d minus mu d divided by SD, standard deviation, divided by square root of n. Okay, you can calculate t-score by using this formula. So a study was conducted to investigate the effectiveness of hypnotism in reducing pain. Okay, results for randomly selected subjects. Okay, a lower score indicates less pain. Okay, just underline it. A lower score indicates less pain. The before value is matched to an after value, and the difference are calculated. And the difference have a normal distribution. I think you're quite familiar with normal distribution. Okay, are the sensory measurements on average lower after a hypnotism test at a 5% significant level? So this is let's say this is the condition. Okay, this is the condition. So you have a number of subjects A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8 items, 8 subjects. So you have 2 cases, 2 conditions before and after. Okay, and you measure the level. Okay, you number the level of pain. Okay, before. For subject A, you measure before you measure it. Okay, 6.6 and after 6.8 for A, for subject A. Okay, and you measure before and after, okay, for every subject. Corresponding before and after values from match pair calculated after before. So you see the table after data, okay, and before data, okay, and after minus before. Okay, you calculate the difference. Okay, 6.8 minus 6.6 is equal to 0.2. 2.4 for subject B. 2.4 minus 6.5 is equal to minus 4.1. Okay, and so on. So at this stage, you get the data for the test. Okay, they are the differences. And the sample mean and sample standard deviation of differences are x bar d. You compute x bar d. Okay, 0.2 plus minus 4.1 plus minus 1.6, blah, 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 and finally divided by 1, 2, 3, 4, 5, 6, 7, 8. Okay, you get xd is equal to minus 3.13 and standard deviation is 2.91. Okay, let mu d be the population mean for the differences. We use the subscript d to denote difference. So random variable x bar d means the mean difference of the sensory measurement. Oh, we still have time, so let's continue. And now you have two types of hypothesis that call H0 being null hypothesis. Okay, and mu d is equal is greater than or equal to 0, and the null hypothesis is 0 or positive. It means that there is the same or more pain felt after hypnotism. That means the subject shows no improvement. If you accept null hypothesis, it means the subject shows no improvement. Mu d is the population mean of the differences. Okay. But if you reject null hypothesis, you accept HA. It stands for alternative hypothesis. Okay, in this case, mu d is less than 0. It shows the alternative hypothesis is negative. It means less pain felt after hypnotism. That means that the subject shows improvement. Okay? If you reject null hypothesis and you accept alternate hypothesis, means there is improvement. The score should be lower after hypnotism. So the difference ought to be negative to indicate improvement. So you can see the distribution for the test. The distribution is a student T with degree of freedom n-1. And the number of data is 8, right? Minus 1 is 8 minus 1 is just 7. So T7. Notice that the test is for a single population mean. And then you calculate the p-value using the student t distribution p-value at 0.0095. So and you can see the normal distribution curve. The p-value is equal to 0.0095. Okay, and the x bar d is the random variables for the differences. The sample mean and sample standard deviation of the differences are x bar d is equal to minus 3.13 and standard deviation is equal to 2.91. So and you compare alpha and the p-value. Alpha is 0.05. Okay, this is the error rate at 5%, and the p-value is equal to 0.0095 when alpha is greater than p-values. Okay, let's make a decision. Since alpha is equal to p-value, you reject null hypothesis. This means that okay, mu d is less than 0 and there is improvement. So let us continue for the next episode, next video.